This is what happens when you let an engineer use AI to try to play Jingle Bells. Halloween is over. It's now the beginning of November and it's time to start on a Christmas project. Last year I did kind of a mini Christmas project where I made a tree that has a bunch of LEDs on it, like this. But this year I wanted to do something different. My plan is to make what I call the Caroling Conifer, which is a plywood Christmas tree that's going to go out on the same stand that the Halloween project was on. It's going to have 8 bells in it. Yeah, so that it'll be programmable so that it can make music. So you can walk by, you press the little button, and it'll play you a carol of some kind by striking the bells. I sat down and I brainstormed how to do this with Claude, which was an interesting exercise because I could send it off to do research on specific parts, and then I didn't have to spend quite as much time reading about all of the different options for solenoids, for example. And I was able to settle more quickly on the exact things that I was going to use, which was kind of cool. The goal now is to start putting a few things together to see kind of how it works, and then to cut out a Christmas tree of some kind. So here we go. I'm gonna have to mount this. All right, so we have this, which is my bell hammer, and it actually works pretty well by hand. Obviously, completely vertical works better because it uses gravity to return this. But also the key thing is that when the solenoid is fully extended, it's not quite to the bell, there's a little bit left. So it's kind of like throwing the hammer to hit the bell. So let's see how it looks when we power it up. It's a little loud. The solenoid is loud. Not letting it hit all the way here helps. Probably if I could get the stroke of the solenoid to just be a hair less than it actually is so that it's not hitting metal on metal. If I can get some rubber or some craft foam in there, then that probably will make a big difference. I have this nice design for the bell. It's got the solenoid and the hammer, and it even has this nice cover to go over it to keep the water off of the solenoid. And then I was holding this up to the tree to kind of see, because it's going to be roughly the same kind of tree. I was trying to see where would this go, and then I bumped this. And it has a really rich sound. And I think I might be hitting the bell in the wrong spot. It's kind of hard to hear, but you have that really rich noise, and this is more tinny. So I did some research, and it turns out that this plastic strike hits the bell right here where there's these double ridges, which has a name, the sound bow. That's this part right here. So that's actually where I want it. I want to hit it right here, basically, with my hammer. So that's not quite right. I've been refactoring the shape that we have here, and now what we have is this shape. So we have the bell at a slight angle, so the plywood backing goes here, so the bell will just stick out a little bit. I have the plate here, a couple of screw holes, cover for the solenoid. It looks a lot like this, so there's a space for the solenoid and some rubber sheeting to reduce vibration. This arm goes right here to hit the bell. And you see I basically am just hitting it with a little screw head so that it's adjustable and so that it's metal and gives it a little bit of weight all the way out at the end there. And so that gives us this so that when this comes down, now what we're gonna do, we've got it plugged in, we're gonna turn it on here and we're gonna compare it to the original setup. It's hard to tell, but I do think that this has a fuller bell sound. This is gonna work really great. Getting some outside help to design a tree. Cutting a tree. That is a Christmas tree. I won't make you watch me paint all of it. This would be easier if I had more clamps. I don't know if I have enough green, so I painted the back gray, and this just needs to set, flip it over, paint it green. We have a green Christmas tree. We have a whole bunch of poorly painted brackets. Plan now is to get these put together so that I have 8 bells with solenoids all attached, ready to go, and then kind of start wiring them up to this and placing them so that I can start programming, because that's going to be its whole thing. First song with 4 bells. Let's see how it does. I think it's going to be Hot Cross Buns. Oh my god. Okay. Well, that's just too good. Okay. I, for the first time, have all 8 bells wired up onto the controller board, hooked up, mounted, everything. And we're going to play them in sequence for the first time. So here goes nothing. Literally nothing.
1 hour later.
Okay. Resetting. Okay, here we go. Trying again. It worked. It sounded like one bell got hit twice. Let's just do that again. It's one of these here. No. You're not being hit twice. Those 2 bells sound exactly the same. Well, that sucks. They sound almost exactly the same. So that's exciting. I think I can play a tune though. Yep, we can play Hot Cross Buns. That's not bad. C, D, E, F is out of tune, G, H, H, how about A, B, C. That's all we got. Okay, just a little bit of Mary Had a Little. Ode to Joy. That's cute. Let's see. That would be better if it was in tune. Jingle bells. That should come from a Christmas tree. Yes. Oh my god, it's so bad. I want to play Jingle Bells faster. Oh, it's so bad, so out of tune. I didn't expect that. Oh, I should have spent more money on bells. I don't know what it's gonna do. Yeah, we're just gonna go for it. Full rushy. It was almost We Wish You a Merry Christmas. I had Claude completely rewrite the rush E attempt so that it was doing it all syncopated and it could play notes in parallel. I ended up not actually putting this outside. I did not expect the bells to be that out of tune. There's no H in music. Claude wrote all of the code that runs on the microcontroller. It made the debugging way more efficient and actually more fun. While Claude was writing code, I would go tweak the position of a bell or do something else to try to refine the sound a little bit. Much as if I had someone doing this with me, but I don't most of the time, except for drawing a giant Christmas tree on a piece of plywood, thanks be. I actually don't mind not writing all of that code, hundreds of lines of code that I have to write myself. I think it's a great symbiotic relationship between Claude and I working on projects like this. I had a ton of fun building it. Now I'm just gonna leave you with Claude's original compositions. Claude wrote me an intro, so I'll read that to you here, and I will leave you with the Caroling Conifer. Yeah, it has this whole thing it did. Okay, here we go. What you're about to hear is not a recording. There is no speaker, no synthesizer, no digital trickery. What you're about to witness is 8 physical bells struck by 8 solenoids controlled by a single microcontroller smaller than a credit card. Each solenoid fires with enough force to ring a brass bell. Here's the thing nobody expected. The solenoids themselves have a voice. That percussive clack of metal striking metal, that's not a bug, that's a feature. Tonight, you're going to hear 3 original compositions written specifically for this 8-bell mechanical orchestra. Each one designed to exploit both the ring of the bells and the clack of the strikers. First up, a full drumline experience with call and response, cascading scales, and absolute chaos. Second, a more musical journey, marching band meets bell choir. And third, pure aggressive percussive fury.